Hi everyone, in this video I'm going to look at frequency tables including relative frequency and cumulative frequency. So what is a frequency? When we talk about frequency and frequency tables, we're talking about how many times a given data value occurs. So this is essentially just a count. We can find frequency in categorical data. For example, I have here a sort of randomly generated list of favorite fruits from different people. So we have a list here that looks like apple, banana, apple, orange, banana, apple, grapes, etc. If I count up how many people list each fruit here, I can create a frequency table. So in this case, in the table I have the different fruits in the first column, and in the second column I have their frequencies. So apple has frequency 7, meaning that there were 7 people, 1, 2, 3, 4, 5, 6, 7 that said apple was their favorite fruit. I'm seeing apple listed 7 times in this list. The frequency for banana was 6, orange 3, grapes 3, and pineapple 1. So this is a nice way to organize your categorical data and list out how many people listed each category or each label. We can also find frequency in discrete numerical data. So this example data set is how many siblings people had. So our list looks like 1, 2, 0, 1, 3, 2, etc. This frequency table would look something like this. So in the first column I have my number of siblings, and all the possible outcomes that showed up in this data set are listed: 0, 1, 2, 3, 4, and 5. And then the frequency of each one of those, the frequency of 0 is 4, meaning that there were 4 people who had 0 siblings. The frequency of 1 is 6, meaning that there were 6 people in this data set who had 1 sibling. The frequency of 2 is 5, 3 is 3, 4 is 1, and 5 is 1. And finally, you can also do frequency for continuous data. In this case, this is an example data set of the length of someone's pinky in centimeters. So we have some measurements here: 4.2 centimeters, 5.1 centimeters, 5.6 centimeters, etc. These lengths vary from about 4 to about 6, but because these are continuous data values, they have decimals, we don't have just specific possible outcomes, it wouldn't really make sense to list out every single possible data value and their frequency. In most cases, these measurements will all have frequency 1, so we wouldn't really be able to see much from that data set and from that level of frequency, and the table would be huge. So when we work with continuous data, we typically will group the data values into particular ranges called classes. This is typical of what we see in histograms. You can also do this for discrete numerical data, especially if there are a lot of different possibilities. But for continuous data in particular, you would want to group your values. So here in the length of a pinky in centimeters column, we have 3 different ranges: 4.0 to 4.9, 5.0 to 5.9, and 6.0 to 6.9. So all of the measurements from 4 centimeters to 4.9 centimeters are grouped together. The frequency of that group was 5, and then from 5 to 5.9 is frequency 9, and from 6 to 6.9 is frequency 6. So we can still see kind of the distribution of the lengths of these pinky fingers without having to look at every single data value separately. Now, it's sort of up to you to decide what sort of ranges make sense. These groupings only result in 3 different classes, and you might want to break it down into smaller groups than that, and you certainly could. But you do typically want to group your continuous data into intervals. Next, I want to look at relative frequency. So you can compute relative frequency for any type of frequency table, but here I have the fruit table. So I have the different favorite fruits: apple, banana, orange, grapes, and pineapple, and then the frequencies that we had found in the previous slide. So relative frequency just means what is this frequency relative to the whole? And we would compute this by taking each frequency value and divide it by the total frequency. So the first thing I need to do is actually find the total frequency. In this case, if I add up all these frequencies, 7 plus 6 plus 3 plus 3 plus 1, I get a total of 20. So that means that there were 20 data values in the entire data set. So if I look at the frequency of apple, so there were 7 people who said that apple was their favorite fruit, the relative frequency of apple would be 7 out of 20. And I can just put this in as a fraction, for example. 7 out of 20 is the relative frequency here. And then compute the same thing for the other groupings. So for banana, I have 6 out of 20, orange 3 out of 20, grapes 3 out of 20, pineapple 1 out of 20. And these are perfectly fine relative frequencies, but they're a little bit hard for us to judge how big each one of these fractions are. So in most cases, we will write relative frequency either as a decimal. So if I take that 7 out of 20 and compute that on a calculator, I get 0.35. That would be the decimal version of the relative frequency. Similarly, the banana calculation, which was 6 out of 20, gives me 0.3. Oranges, the frequency 3 out of 20 gave me 0.15, another 0.15 for grapes, and then finally pineapple, 1 out of 20 is 0.05. So these are the decimal versions, and the decimal versions are a little bit easier to work with because we can easily see which numbers are bigger than others. Or even more commonly, we will see relative frequency converted to a percentage. So rather than 0.35, we would write that as 35%. Rather than 0.3, we'd write that as 30%, etc. For a categorical data set like this, we might use a pie chart to represent these relative frequencies, or a bar chart to represent the frequency or relative frequencies to compare these different categories. If you want to use Excel, if you have your data set in Excel, it's very easy to create relative frequency tables from a frequency table. So here's an example frequency table that I created looking at school enrollments at different schools within Colorado. And here is that same table showing up in Excel. So if I have the frequencies already, I'm going to make a column right next to this called relative frequency. So my first column is the school enrollment ranges, the second column is the frequency of each of those ranges, and then I'm making a third column for relative frequency. Just like before, I need to know what is the total frequency, so I'm going to come to a box underneath my frequency column and use equals sum, and that sum function, so equals SUM parentheses, I can highlight all the frequencies, close my parentheses, and press enter, and this tells me that there's a total of 225 data values in all of these different categories. So when I come to relative frequency, I'm going to click in this first cell. I'm looking at the school enrollment range from 0 to 499. The frequency of this range was 164, meaning there were 164 schools that had enrollments between 0 and 499. So really I want to take this 164 divided by 225. Rather than typing in 164, I'm going to click on the cell there so that I can have this calculation work for all of the different enrollment ranges. I am just going to divide by 225 here because I don't want the total number to change. So I'm going to divide by 225 in all of the categories. So equals B2 slash or divided by 225. This gives me the relative frequency as a decimal of 0.278889. And I'm going to click on that cell again and then grab the lower right hand corner to drag it down and do the same calculation for each one of these rows. So for example, in the second row, it's taking the frequency of 51, which is in box B3, and dividing by 225 again. So by dividing each one of those frequencies by the total, we get these relative frequencies as decimals. I can also convert these to percentages if I wish. So in the Home tab under Number, I can click this percentage value and it will give me percentages. You can also add decimal places to this if you want. One last type of frequency table that we sometimes use is what's called a cumulative frequency table. So coming back to my number of siblings example, my frequency table looks at each number of siblings and then counts up how many people had that number of siblings. So 4 people had 0 siblings, 6 people had 1 sibling, 5 people had 2 siblings, etc. A cumulative frequency table is going to look at not just each individual number, but each number of siblings or less. So I created a second table here where I have the number of siblings listed as 0, which is the same as the regular frequency table. The frequency here would be 4. And then in the next row, instead of just having the number of people with 1 sibling, I have the number of people with 1 or fewer, or 1 or less. In this case, that would be the numbers 6 and 4 added together, or 10. In the next row, I have 2 or fewer, or 2 or less siblings. This would be 4 plus 6 plus 5, just those 2 and below numbers from before. This is 15. And we can keep going through all of these values. So my cumulative frequency table shows 1 or less or 1 or fewer siblings has a frequency of 10, 2 or fewer 15, 3 or fewer 18, 4 or fewer 19, 5 or fewer 20. Notice that when you get to the last category, that frequency should always match the total of the entire frequencies from the original table. That's it for this video. Thanks for watching.